Corporate valuation is one of the main activities performed by finance professionals. Often models are created with this purpose. The problem is that many of these models show errors that might significantly affect the final results. In this series of micros, I will share with you many of these errors and how to cope with them in practice. In this first micro, I will focus on terminal values, in particular, terminal values when they are assumed to be growing perpetuities. Let's get started. When performing a company valuation, it is customary to assume a terminal value, as I said before, representing the present value of a growing perpetuity. The common practice is to equal the first cash flow of the perpetuity to the last free cash flow of the projection, plus a predetermined growth rate. Let's illustrate this through this example. Imagine that we are doing the valuation of a company, okay? And we have a total of 20 years of cash flow projections. We are going to focus on the last 3 years, which is years 18 to 20. We obtain the unlevered free cash flow for these 3 years in the following way, just by taking EBIT for each year, which is earnings before interest and taxes. Then we subtract the taxes, and then we obtain what is called NOPAT, net operating profit after taxes. And we will elaborate about this in particular later on. Then we add back depreciation and amortization. We subtract investment in net working capital. And finally, we subtract CAPEX, which is capital expenditures. So after we do all these, we can obtain then the unlevered free cash flow for years 18, 19, and 20. In this case, we obtain 920, 1010, and 1060 for each of the 3 years. Starting in year 21, then we are going to assume a perpetuity that will represent the terminal value in year 20. And for this, we are going to assume a growth rate for the perpetuity of 3% and a WACC rate, which is the discount rate that we are going to use to discount the cash flows, of 10%. So a common practice is to take this last cash flow, 1060, and then to add the growth rate as it is shown in this formula, okay? We add the growth rate, so 1060 plus 3%, we obtain 1092. Then this number is assumed to be equal to the first cash flow of the perpetuity. And then the terminal value is calculated just by discounting this number, 1022, as a growing perpetuity, meaning that you have to divide by the WACC rate minus the growth rate, 10% minus 3%. And you obtain a final result of 15,597 for the terminal value of the perpetuity starting in year 21 with a growth rate of 3%. And that terminal value will be the value, the present value of this perpetuity in year 20. We must criticize this approach, basically because this approach treats the growth rate independently from the magnitude of the last free cash flow. What do we mean by that? What we mean is that if you assume a certain growth rate, if you pretend to grow after year 20, you must invest before that. You must invest in the last year of the projection. In our example, in year 20. So if you plan to grow starting in year 21, then you must invest in year 20 in order to make this growth possible. Okay, and the higher the growth rate, the more you must invest in year 20, and in consequence, the smaller the amount of the free cash flow at the end of the projection. The other factor that we must take into account is the return on this reinvestment that we must make in order to grow. Okay, this return is called ROIC, meaning return on invested capital. The higher the return on invested capital, the less you will have to reinvest in order to keep a certain rate of growth. In sum, the growth rate is defined by these two factors. The first factor is the proportion of free cash flow to be reinvested, that we will call B. It's also known as the plowback ratio. B multiplied by ROIC. ROIC is, as we said before, return on invested capital. So the growth rate will be defined by this formula. Let's elaborate on this a little bit. We must recall that the free cash flow is given by EBIT plus depreciation, minus taxes, minus capex, minus investment in working capital. If we start from a base case in which we are assuming no growth, meaning that the perpetuity representing the terminal value in year 20 will not grow, we will have just a steady cash flow. Okay. In this base case, if this is what is going to happen, then capex, capital expenditures, must exactly equal the depreciation, so that we are only just replenishing the equipment that is being wear out. Okay. And given that we are not growing, working capital doesn't change over the years, so the investment in net working capital, year by year, investment in net working capital will be zero. So, under the scenario of a not growing perpetuity, the free cash flow, the last free cash flow of the projection, will be equal to EBIT minus taxes. This is what we call NOPAT, that we mentioned before, okay? Net operating profit after taxes. But if we want the perpetuity to grow, which is the common case, we demand a certain permanent capital investment. This capital investment will be capex plus investment in working capital. And this investment will be always a certain portion of NOPAT. The higher capex plus investment in net working capital divided by NOPAT, the higher the absolute amount of capex plus investment in net working capital, the more we'll be able to grow. So the last cash flow of the horizon, we know, as we said before, the last cash flow of the horizon must be equal to NOPAT plus depreciation minus capex minus the investment in working capital. Being a perpetuity, the ratio to invest, meaning capex minus depreciation plus investment in working capital divided by NOPAT, must be constant. And the growth rate will be equal to this constant, which is the plowback ratio, multiplied by the estimated long-run return on invested capital ROIC, as we said before. So let's go back to our example, but now we are going to slightly modify. The last three cash flows are exactly the same as we had before. We also have the same assumption, the growth rate of 3% for the perpetuity and the WACC rate of 10%. But now we add a third assumption, which is ROIC. Okay, ROIC will be 12%. This is our assumption here. So the first thing that we must do, and this is the way I believe we should do this calculation for the terminal value, the first thing that we must do is to modify the last cash flow of the projection in order to make it compatible with the growth rate that is assumed, 3%, and the ROIC that is assumed, which is 12%. As we said before, the growth rate is given by B multiplied by ROIC. So B is equal to G divided by ROIC. In our case, given that G is 3% and ROIC is 12%, then the growth rate, the plowback ratio will be 25%, okay? 3 divided by 12. So the proportion of NOPAT that we must reinvest must be equal to 25% in order to achieve this growth rate of 3%, assuming a return on invested capital of 12%. So we recalculate our free cash flow for year 20, for the last year of the projection, in this way: NOPAT multiplied by 1 minus B, the plowback ratio. In our example, it will be NOPAT is 1150. Remember that NOPAT in year 20 is 1150. And then we multiply by 1 minus the plowback ratio, and we obtain 863. 863 then will be our modified cash flow for year 20. And this modified cash flow is compatible now, is consistent with the growth rate of 3% and the return of 12% on invested capital. Now we are ready to calculate the terminal value in the right way. Okay, terminal value will be the first cash flow of the projection in year 21, which will be 863 plus the growth rate of 3%, and then we divide that by WACC minus G to make it the present value of a growing perpetuity. So our final result will be 12,691. And we can observe that this number is significantly different from the previous wrong value of 15,597, okay, the value that we obtained before. So this is what I wanted to point out in this first micro. This is all I have to say for today. Thank you very much. Until the next time.